The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Okay, our final speaker is Philip Lozenzo with Rithm. Philip is the founder of Rithm, a technology company dedicated to simplifying the process of inspection, monitoring, and quality control analysis of concrete. He's the chair of technology for the U.S. Institute of Building Documentation and active within ASTM, ACI, and ASCC as an expert on reality capture. Prior to Rithm, Philip worked as a construction engineer at McCarthy. He obtained his bachelor's degree in civil engineering from the University of California, Berkeley. The title of his presentation is Leveraging 3D Laser Scanning for Concrete Analysis. Please help me welcome Philip Lozenzo.
Appreciate the introduction. By the way, I think there might have been a typo in my last name. It's Lorenzo, with a Z. Yeah, no, it wasn't your fault. Actually, I might have typed it wrong. So, has anyone here heard of 3D laser scanning as a technology? Can you raise your hand, please? Oh, it looks like everyone. So when I first came to and joined ACI a few years back, it looks a much smaller percentage of hands. People raise your hands. Maybe it must have been 10% or less. So the reason why I've been invited to speak is to discuss what 3D scanning is for those who maybe just heard about it, but maybe don't know the real main use cases of it in concrete. Is anyone here? Is anyone here a concrete contractor? Could you please raise your hand? Anyone here an inspector? Anyone on the design side, engineering side? Perfect. One thing I'm just in terms of objectives for today is not only introducing the technology itself and how it's rapidly being adopted and it could influence concrete tolerance checking, but there's also some work that we're doing in ACI 117, the tolerance committee, that I'd like to share and also get some feedback from everyone here. So let's go on. So here I'm just gonna keep going. Yeah, I was already introduced. So for those of you here who didn't raise your hand, or maybe you've heard of 3D scanning, but you don't know how it works exactly, what you take is you take one of these machines. This is one example. There's about half a dozen other manufacturers out there. I'm not really, I can't be biased towards one. I need to be neutral. But most of the current generation of scanners today, they will capture points at 1 million points per second. You hit the button on the machine, it'll spin around for about 2 minutes. It'll spin around one time, and it collects 1 million points a second. And so you can capture this whole room, the concrete, in probably about 4 minutes total. And you have practically every square inch of this room, the concrete of this room mapped, including the walls, including the ceilings. And you can do things such as you can do FL analysis, you can monitor stuff, and which are some workflows that I'll showcase here in a bit. Accuracy of individual points are 1/8 of an inch. That's actually, this is a bit outdated. The current generation of scanners are accurate to, it's 1 millimeter, so I think it's a little less than 1/16 of an inch. But there's algorithms you can apply to points and sampling so that you can get to about 1,000th of an inch. So you can mimic certain devices such as profiling devices that require a high level of accuracy for meeting things such as ASTM 1155. It's also self-leveling, so this is just kind of, many of these stats are pretty typical of most modern 3D laser scanners, and it's definitely come a long way in terms of price, in terms of ease of use, and that's the reason why most of you here have probably heard of 3D scanning and probably have seen it on some of your projects, for better or for worse. So the way it's done is, I'm just going to skip over this. What people typically do is when you start a scan, A scanner can only see from the perspective of where it's currently taking its scan. It does a 360. But if there's a column in the way, or there's people in the way, or maybe there's a wall and you want to capture the other side of a wall, you'll have to move it into multiple locations. So each position is going to be another 2 or 3 minutes. And there's a process called registration that requires you to be able to put all these points, all these different scans into one single scan. We call this a point cloud, which is a gathering of all the points captured on the job site. And it's pretty straightforward to master, but the real benefit here is what can you do with those points. Just like we have when you just take a photo, it's just a bunch of pixels. There's a lot that you can do with it. Does anyone have any questions so far? Is this pretty straightforward explanation of scanners? Perfect. So, okay. So when let me go a little bit in chronological order. When implementing, I'm gonna use a sample, a DPR construction. They've been highly involved in adopting 3D scanning technology and essentially standardizing it within their companies. But with any new technologies, there's a level of challenge. There's lots of challenges in terms of understanding how scanning technology can meet current standards, how accurate these new methods are compared to traditional tools, and developing that trust with field foremen and just project teams in general who are not familiar with technology. It requires, some people say that at the end of the day, technology is really, it's 10% software and hardware, and it's really 90% people and their understanding of how to best use it and their trust level of it. And then also determining what kind of value they can get in adopting this new technology. So one thing that this company did is one of their big goals is to see how they can use 3D scanning to supplement their efforts in checking for traditional ASTM for flatness measurements. For most, I'm sure everyone here is familiar with that. You have a minimum length, you have a certain number that you have to do, and you have to do it in a certain way. And being able to do that with this machine has its benefits. I can kind of show you an example here. We have here is, okay, this might not look exactly parallel, but you can easily, with a point cloud, draw lines on concrete, make parallel perpendicular lines, and then output in a really quick manner an actual ASTM compliant report. That is what the technology is capable of doing today, and this particular company has done it. It's been a few years now. I personally was actually part of the ASTM 1155 2014 revision. That revision actually includes in an apparatus section that 3D imaging and 3D scanning technology can be used for this. So if you have any inspectors that might be questioning it, it's in the latest version. Anyone have any questions so far about scanners and ASTM? Getting the workflows down is anyone who's adopting this firsthand, there's a lot of workflows associated with getting a guy out to, with a scanner, making sure their batteries are charged. I mean, that's typical of any new hardware that you might get. And then the training required so that when you have someone scan for this type of reporting, being able to make sure that if Joe here and Mike here scan, that they'll get the same results. And making sure to document your process is important to create repeatability when implementing this. So let me just kind of go out. Is anyone here a contractor, someone who is a general contractor that self-performs concrete as well? Okay, so most people here are contractors, right? Okay, I'm gonna skip this part right here. So there's a certain level of understanding of your site logistics that you have to take into account when capturing your concrete with this technology. One great use case for when you're using 3D scanning technology is to be able to scan concrete while it's still workable. 3D scanning is a non-contact type of device, which means that you can actually follow your crews going from, say, pour 1 let's say you're pouring a floor in certain sections at a time. You have your crew finish one area, and then you go to the next, and you go to the next. When the crew is done screeding one area and they go to the next area of the job site, you can actually go and scan. You can see where things are high and low, and as long as you're not in the way and can quickly relay this information back to the crew, there's actually they can actually go back and fix it before the concrete sets. So that's actually a workflow that's being, I think it might be demoed by Largo at 4 p.m. later today, but that's becoming pretty common use case, and it's a unique property of 3D scanning technology. Does anyone have any questions on that? Move forward here. So what does the future have, in scanning? So we talked about how 3D scanning could meet some current standards. There's other use cases for this. So one thing that's currently being required by some owners, especially ones that have high-end finished, like projects that have, like, say, hospitals or data centers, or those who have higher, maybe certain requirements for their concrete, they're requiring the delivery of these heat maps. And when I say heat maps, it's not actually just looking at the temperature of the concrete, but it's actually giving you the highs and lows of the concrete at every square inch, and then being able to overlay a floor plan on that for downstream flooring operations and stuff like that. This is presenting a problem to concrete contractors because this work is currently being performed, it's being specified by architects and owners and then performed by, say, surveyors, but they're not actually using, like, current established ASTM or ACI practices. So that's one of the things that we're trying to address in the ACI 117 committee, is how do we get ahead of this wave? How do we ride this wave instead of being swept away from it? I personally believe that to leverage this technology positively for the concrete industry, how this should be standardized and implemented on projects should come from a body of knowledge familiar with concrete, such as ACI. So addressing how this is done and delivered is one scope that ACI 117 is currently addressing. And we have to, because a lot of owners are starting to realize that in current testing practices, and I'm saying maybe not necessarily on your projects, but in many projects, when you check for FFFL traditionally with lines, you're missing a lot of what's in between these lines. You might have a high or a low spot that might affect your score in the positive direction or negative direction. It could mean the difference between passing or failing. So being able to create a higher level of repeatability and consistency with scanning data is of high interest for a lot of concrete folks that I've spoke to. There's also a lot of other uses when it comes to scanning concrete, or just scanning throughout the concrete pour process. Many people and owners are requiring scanning of a rebar, or say you have PT cables, for example, before pouring. Because when you scan for these elements, you get the locations of everything down to the nearest 1/8 or 1/16 of an inch, and being able to, ahead of time, when instead of having to have someone go and x-ray it and drill through the concrete, having that information ahead of time is of great value. Another common use case for this technology is for ADA ramp and slope analysis for both ramps as well as parking garage inspection. Does anyone here do parking garages? Raise your hand. Okay. So there's being able to check this, and also being able to check this while it's still workable again is something that this technology is currently enabling. Another one is stair inspection. So one example is over at Berkeley, what they required, like there was a bunch of students tripping on stairs, and looks like there was some pending lawsuits, so they wanted their stairs to be scanned for tread height and tread width. And being able to scan stairs and then quickly investigate along multiple paths along that stair where things might be too big or small is something you could do. I think this also was a potential topic of research for the ASCC. Another thing you can do with 3D scanning technology is estimate clearances in parking garages. What you can do is you can measure both the top and the bottom of something as well, so you can get thickness of deck as well as thickness of beams. And you can also monitor that over time. When you perform a 3D scan of an area, you can come back multiple times and in an automated fashion, look at the exact same spot and then see if it moves. So I know I'm getting a little bit out over here, but I guess let me skip past this. Here's an example of Pancal builders. This is at about 3:30 a.m. out in LA. I'm working with a concrete crew. This is kind of what a typical setup would look like if you're working with a crew on ensuring that you can pass your FFFL inspections ahead of time. You can just have say like a Windows type laptop right here, and then the crews are, we got the core part of the building right here in the middle, and they're going around. So if you just kind of follow behind them, you can quickly see where highs and lows are. You can see right here, there's a reds right here are high, and they're about a 1/4 inch high, and then blue is a 1/4 inch low. And so what we're able to do within a span of 7 minutes was tell the crew where to come back so they can go and float things down. And we have found a positive correlation between being able to fix things in the field and higher FFFL values, and also potentially reduced work down the line for other trades. So another thing that this technology can be used for is to investigate cambers of beams, and also seeing how that camber changes after it gets loaded with concrete. One, I think it's many people here are aware of the potentially conflicting tolerances with regards to metal decks and cambered beams, and being able to protect yourself when, say, beams have cambered a bit too much compared to design is of interest, and something that you would capture, say, potentially when you're scanning concrete below and you have steel above. You can potentially kill multiple birds with the same stone with that use case. So let's rewind back again. Let's say what happens when our assumptions change in terms of checking tolerances for concrete. The ASTM 1155 right now, this says that it's based on the assumption that since all of the infinite potential profiles to be seen by traffic cannot possibly be measured, we have to take a statistical average of a floor. Now that we have the ability to have, now that we potentially now do have a way to easily and economically profile an infinite number of ways, on a concrete floor, how does that change our assumptions? And so that's a really big question that we're trying to answer in the ACI 117 laser scan committee. So there's we're doing a lot of work with ACI. We're talking with ASTM in terms of creating a new committee that could help specify how laser scanning is done on projects checking tolerances, and we're also seeing how we can collaborate with folks from the AISC. And we're in a unique point in time in our industry where we can really measure very thoroughly everything on a job site. The saying goes, measurement is the first step to that laser control and then eventually improvement. So the question here is, what would a future standard look like? Let's say we were to create a new standard that leverages 3D scanning technology to help make things more repeatable, because when you scan something, you have the entire floor, and so no matter who captures the floor, we'll all have the exact same data. So what kind of mathematics would be involved to create a single score that would be repeatable no matter who does it and no matter where you do it, with no matter what equipment? How can you leverage all the information, and then how can a new standard be leveraged by a normal, typical industry standard contractor? So the reason why that we're trying to look for a new standard, and the reason why it's coming from ACI, is that being able to get input from concrete contractors to make sure that you're not being held to a higher standard by owners. That's one of our biggest goals. How we also be able to use scanning technology and create a standard that also meets the need that can be done with current tools, such as toll stations or profiling devices, if you had enough time. And so those are some of the guidelines that we're looking at following for the development of a new standard for scanning. We're also looking at potentially partnering with universities. There's lots of master's and PhD students that are hungry towards contributing to the knowledge of tolerances with 3D scanning data. There's universities out there that are getting their own scanners, and they're scanning local job sites to help potentially create new standards. There's a lot of momentum here. So I'm going to end my presentation with a call to action. I invite everyone here to be part of the conversation that we're having on laser scanning within the ACI and how it can be leveraged in a good, positive, and responsible way for the concrete industry. If you have any questions, please come up to me after this presentation. Does anyone have any questions? Good.